A feedback effect in physics or engineering means that the outcome of some action affects the cause of that action. Here's an example on climate change. Suppose in the Arctic the temperature goes up. Just a random fluctuation. A little warm front comes through, a little extra solar energy is absorbed, whatever. Some random fluctuation, and the temperature goes up by a little bit. Well, when the temperature goes up, the Arctic ice cover goes down, because ice melts when the temperature is warmer. With less ice cover, that means there's less light reflected back into space, and consequently, more light absorbed from space, which means more energy absorbed from space, which means the ocean gets warmer, which means the temperature goes up. This is called positive feedback. The effect amplifies the cause. Now, it's not positive because it's good. This is a runaway situation. The temperature goes up, and so a bunch of processes come into play, which makes the temperature go up higher, which makes the temperature go up higher, which makes the temperature go up higher. It's a runaway effect. Simultaneously, however, the temperature going up doesn't lead to just one outcome. It leads to other outcomes as well. Because when the temperature goes up and the Arctic ice cover goes down, so the light reflected goes down and the light absorbed goes up and the ocean gets warmer, well, warmer water evaporates more easily. And so evaporation increases. Evaporation leads to clouds. Clouds are excellent at reflecting light back into space, and more reflected light means less energy absorbed, and that means the temperature goes down. This is an example of negative feedback, where the effect suppresses the cause. Now again, the word negative is not because it's bad. This, in fact, is good. This leads to a stable situation in which, as the temperature goes up, the result is that the temperature goes down. It's very much like the thermostat in your house. When the air in the room is too cool, the thermostat turns on the furnace. As the air warms up and gets to the temperature you've set the thermostat at, the thermostat shuts the furnace down again. It leads to a stable situation and a constant temperature. But the difficulty is that both of these effects are going on simultaneously, and it's not clear which, in any given circumstance, is going to win. And it's not just this one effect, because there are huge numbers of factors that come into play. There's small changes, as we've seen, in solar output. There's changes in the circulation of the atmosphere, and also, as a consequence of our activity, the composition of the atmosphere. There's changes in clouds and the hydrologic cycle. There's interactions between the atmosphere and the biosphere. There are volcanoes. There's the cryosphere, the ice cover of the Earth, and its interaction with the oceans. There's land use changes and a whole bunch of human influences. And all of these things are changing, and most of these things are linked together in a complex set of feedback loops, both positive and negative. The consequence of this, that to put this model into a computer requires literally millions of lines of computer code and the largest supercomputers in the world to run, just to get the simple equation, energy in equals energy out, change some of the parameters, and see what the future of climate might look like.